Jeez.
Get it together.
Okay, 54. We have, there's a couple ways of thinking about this one. G of x equals x squared minus 1, and I'm going to say f of x up here is x squared. So if I start with my original function, if f of x, I'm trying to think of a different way to do it. Let's make our table first from f of x. If I use just the points -2, -1, 0, 1, and 2. Okay? And I plug those in, I'm going to get 4, 1, 0, 1, and 4. This is f of x. So now g of x, in theory-wise, I'm going to kind of talk about this. In theory-wise, could I write, since it says g of x is this, right? Could I write it like this? G of x is equal to f of x minus 1. Same thing? Now it's like the problems you just got done doing. Correct? So what did we do in the previous problems? Nothing happened to f of x, right? But what happened at the end is minus 1. So the minus 1 on the outside, what does it do? Moves what? So what variable? It takes the y and moves it down 1, so we're going to subtract 1 from the y coordinate, right? X coordinate is 54. The x coordinate's going to stay the same, and the y coordinate's going to move down 1 unit. And then I would graph that, and that's my new graph. Does that make sense? So that's a nice, I always kind of like to see if I can write it like this, because then you can kind of see it from the previous problems, how it works. The other thing I want to mention again, and this is a little review, if I have an equation, I'm just going to say a times f bx plus c plus d. That's kind of what we have, right? That's the whole thing. B and C here are inside the parentheses. If it's inside the parentheses, it's me stating this, it affects the x, and it's always the opposite. Inside is opposite. In other words, if I'm adding 1, subtracting 1 from the x. I times it by half, times it by 2. On the outside, like the a and d here, this is the outside, I am affecting the y's, and it's exactly like it says. It's 2 in front, I'm multiplying by 2. Minus 2 at the end, minus 2. That make sense?
Yeah.
Okay. What's your other ones?
Can we do 61? I did it, I don't know if I did it. Yeah, 51.
A 60? A 60. I'm going to use this points up here. 60, help me out. Is y is equal to x minus 1
Squared plus 2.
squared plus 2. Okay. So what do we have here? We use the same points, right?
Yeah. What is h of x?
So h of x is just another function. It just means this is the function I'm graphing. Okay. So could I write this as? Could I write this as this? F of x minus 1 squared plus 2. Because if I plug x minus 1 into x squared, it would give me that, right? Okay, so if I do that, my original points again were -2, -1, 0, 1, 2, 4, 1, 0, 1, 4, right? Now what we're going to do is inside it's minus 1, so we're going to take all our x's and add 1. So we're going to get -1, 0, 1, 2, and 3. All our y's, the plus 2 at the end, we're going to add 2, so we're going to get 6, 3, 2, 3, 6. That would be our.
With the order of what which one you're doing is basically it's like order of operations, parentheses first, and multiply it.
Kinda, yeah. Inside the parentheses, I always do. Okay. I always do the.
Horizontal shift.
Vertical shift, horizontal shift, it doesn't give you the order.
Yeah, it says
It says
horizontal shift.
horizontal.
Yeah. Yeah, that's what it's thinking. Now, if horizontal, I always do left and right, then I do the stretch and shrink, and then I do the left. And then on the outside, I always do the, it doesn't matter which order, but do the multiplication on the outside, the stretch and shrink and the reflection. The last step is always the up and down.
Do 57.
South Francis outside of Quincy, and then adds back outside of
50 what? 57? Negative f of x minus 2 squared. So we got y is equal to negative x minus 2 squared. So really this is y is equal to a negative f of x minus 2. Right? No, because f of what was f of x? F of x was x squared, right? So if I took f of x minus 2 means if I take this and plug it into x squared, right? I'm going to get this, okay? So I just can write it like this so I know what I'm doing here. So from here, what am I doing with my graph then? Yeah, I'm going to move to the right 2, so I'm going to take all my x coordinates and add 2 to them, right? And then the negative on the outside is going to flip it across the x-axis, so I'm going to take all my y coordinates and multiply by negative 1. So,
What is this? 51.
can I do which one? I'm just gonna talk. I'm not gonna find the points every time, but can I just talk about it? So on this one, I got f of x plus 1. I believe it is, right?
Yes.
So what is this doing? From the inside out, we're gonna take the plus 1 on the inside is gonna move my graph to the left 1 unit. So I'm gonna take all my x coordinates and subtract 1. The 1/2 on the right outside, take all your y's and divide by 2. And so if I'm dividing all my y's by 2, what's going to happen to my graph?
What do you do with the x's on
Shrink. X's, you're going to subtract 1. And then on the y's, you're going to take all the y's by 1/2. So it's going to take all my y coordinates and split them in half. So it's going to shrink it down, correct?
So if the 1/2 on the outside, it shrinks, if 1/2 on the inside, it stretches.
Always the opposite. That's what the QE is saying. I think a lot of people get confused on that part. When you do the test, it's like one of those blank on it, you know? My thing is, if you're doing this part of the test or quiz coming up here, my advice would be to come up with a pattern, come up with a rule that you think you're going to remember what way, you know, very easily. The only time you have to memorize is for all 20 seconds. The time it takes to do your test and whether or not you can do it.
Remember that.
Remember a rule.
Remember a rule, like, so if I'm remembering that inside x, outside y, it's the opposite inside, whatever. Get your test right away, sit down. You write it on the desk, it's cheap. If you get your test and write it on the test real quick, it's okay. Remember it for that one. So that's the way where I would do your test. That's why it's important to take this yes right next to my desk, because it's not very far along. You got less time to worry about it. So, any other?
Can I just like make sure I wrote this down right? Okay, when you have 1/2 on the outside of the parentheses, you multiply it times 1/2, and then 1/2 on the inside, multiply it times 2.
It really, actually, when you think about the inside, probably, when you think of the inside, I always think of the opposite, right? When it's in the inside, you're really multiplying by 1/2, right? So really the opposite is dividing by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. So you're really dividing by 1/2, but I just did
The
multiply.
same.
So let's say I asked you, how would, if I gave you this one, let's look at number, I think you're doing by 3's, correct? So let's see, the third one. 78. There was X plus 78. That's one last one. You know, if I had this equation, these are the two equations I asked you to graph. I know you could plug points in and get points out, but I want you more think into this, you know? You know, you're given an equation here and say, how does it work? A lot of times I want you to think and say, how does this affect this? Okay? So if I was looking at this, these are both square roots, right? So this is f of x is this, right? So could I write this equation as f of x plus 1? That part. In other words, I'm taking x plus 1 and plugging it into there. Would that give me the square root of x plus 1? So I see a couple looks. What does f of x plus 1 mean? left, but what it means is, I mean, just not talking left or right. It means take my f function and wherever I see an x, plug in. So what would I get? I would get this, right? So the 1 would be like under there, right? Then I have minus 1, right? Minus 1 and also. How would you know that you're going to have square roots? What I want you to think about is that I'm going to give you this original function sometimes. Then you know you're working with the square root function. And now what I want you to say is, how does this function and this function relate? So what I'm saying here is, this function here, right, is taking the original function and moving it to the left 1 unit, and it's moving it down 1. When you write it in that form, you can see it very easily when you left and right. And that's kind of why I want you to get used to writing it that way. You know, so that way it says, okay, for example, going the other way, I'm just going to do a very easy example.
So you just get rid of the square root?
Yeah, because you're just writing it as the original function.
It doesn't affect it at all. Okay.
So let's say this is my original function. Okay? And I'm saying this is at 1. Okay? There's my new function. So what happened? I flipped it across the x-axis. So how could I say g of x would be, could I say g of x is equal to a negative f of x?
What is up?
So because I took all my y values and made them negative, then I need an equation. No, that's kind of what I'm saying. When you write it in this form, you get used to not having an equation and doing a lot of work without an equation. And that's what we want to do. So I mean, I can write it a lot of different ways here, but I mean, I'm saying this way, I'm just saying this is the function. How is it related? G of x, now if I didn't give you this graph, if I did not give you that graph and I said, okay, here's f of x, here's g of x. You don't know what the graph looks like, right? How are they related? The y's are negative. Just flip across the x-axis. I don't need a graph. I don't need an equation. I don't need anything else. That's what I want to do. So I know what's happening when you write it like that form. Could it be a square root function? Could be. Could it be a cube function? Could be. We don't know. But I know that whatever function it is, it's flipped across the x-axis. We don't want to. We're generalizing for all functions when we do it this way.
I'm not a problem with the absolute value of two.
Yeah, how did you
So
do
pretty
it?
much anything.
Any kind of equation will work in there.
Then you just take the square root of whatever it is and use times two.
You're just saying, you're taking the f function. You know, there's a couple ways of doing it here. Okay, let's think of this one. Okay, here's my f function. Okay? This is another way of thinking of it. Here's square root x, right? And my g function was this. Correct? Let's start here. Here's f of x. If I wrote f of x plus 1, what I do to one side? So wherever there was an x here, I put x plus 1. Wherever I put an x here, I'm going to put an x plus 1. That makes sense. What I do to one side, I do to the other. Does that make sense? I do to one side, I do to the other. I'm just kind of taking it from this step. How do I make this equation into this equation? So now what is g of x? G of x is, these two are exactly the same now, right? So g of x is this. Does that make a little bit of sense?
Yeah.
So like on the like Jacob said, the absolute value. Let's look at 93. You must have to do, right?
Yeah, we're on
You're doing it today, so 93. 93, we have this. We have f of x is equal to the absolute value of x. Okay, and I'm going to put down here g of x is equal to a negative 2 absolute value of x plus 4 plus 1. Okay, there are two equations, right? Kind of want you to think about how this is working. First of all, you'll notice there's an x plus 4 inside here, right? So I'm going to start with that. I'm going to say what, and again, it's all what you do to one side, you do to the other.
And you know what which one to take to
So I know there's an x plus 4 inside here.
Wait, does it give you that model?
Yeah, they give you that
And
model.
it says it
They give you this, and you say, well, we want to graph this. So what I'm saying is, okay, you notice here I got x plus 4 inside here. So I'm going to start with the inside, work our way out, right? And in parentheses. What's on the outside now? So I'm timesing by -2. So I'm going to take times by -2. Okay, and then add 1 on the outside. Okay, now are we 2 where we want it to be? They're exactly the same, aren't they? They're exactly the same. So now what do we have? We have g of x is equal to this, correct? So what does that tell me I have to do? Up left 4, I would multiply my y by -2, and then I would add 1. Now be careful with up 1 because we want to multiply by -2 first, and then add 1. We add 1 first, then multiply to 1.
So like, is that your answer right there, that possibly
This is a way to think about how we're moving it without knowing the equation. And so now you have your x coordinates, okay? And then you say, okay, I'm going to look 4 units this way, 2 units down, 2 units
So
down.
you're just doing, like, to get to the bottom, you just added
Yeah, I'm just adding 1 step at a time to get to show you that make this equation that I started with into here.
You want us to do that every time, or can you just change?
If you could do it by in your head, you can see it, then just do it. But I mean, I just think I wanted you to see where the step by step came from. Because these two are the same, it's just that, you'll notice I don't have absolute value here. It just says take whatever function you have. Most of the time, what you have in your head, like if I was dealing with the x squared graph, okay, you're going to have the 5 points in your head that are -2, -1, 0, 1, 2, or 1, 0, 1, 4. You know those points in your head, and you say, okay, what do I have to do to those points? Subtract 4 from the x's. Times by -2, subtract 1, right? You're doing the absolute value. I have a -2, -1, 0, 1, 2, right? On the side, absolute value just makes anything positive, so I'm going to have 2, 1, 0, 1, 2. I have those points in my head. Now I'm going to say my new points are going to be this. I wanted to get to the point where you're not having to write down both sets of points.
Okay, so you want us to do that.
To a point, if you can, yeah. You have that table in your head, and then you say, okay, I'm going to subtract 3 from the x's.
So it's okay if you don't show us.
I want to see the points, yeah. But I want to be able to do it as you go. Okay? Yeah. So that's kind of where I want you to get to, guys. Just thinking in the points, square root. Now, this is a common problem. Someone says, well, I got square root of x. I'm going to try a -2, -1, 0, 1, 2. Well, square root and plug in negative. And I'm not going to use those numbers either. What I'm going to use is 0, 1, 4, 9, 16. Why? Because they're all extra roots. Make easy numbers out of it. Don't use decimals. Then you say, okay, I'm going to move to the left, 2, 1, whatever. That's why use numbers that are easy to work with, easy to remember. And once you get used to doing these problems, and I know I didn't say a lot of them, but once you get used to doing these problems, you have those tables memorized. It's just easy to think of, okay, by x, I'm moving to the left 4 units. If I use -2, -1, 0, 1, 2, I'm still okay, -6, -5, -4, -3, -2. My y's, if they were the other ones, I'm times it by -2 and adding 1. Well, my first y was a -2. -2 times -2 is 4, plus 1 is 5. That's my first point. You can do that in your head. You don't have to write it down. That makes sense. And I think seeing this, where we're used to this f of x plus h and stuff, is easier than seeing this. But that's the thing. When you can write it like that, it's easy to see. I mean, it is the same thing, but it's just easy to see. That makes sense. What's the 1, 7 on?
Oh, you adjust way. I'm guessing that's.
I'm just wondering, 'cause, like, I don't.
What we're going to do is we're going to take these functions and we're going to do a composition of these functions. What we're going to do is take one function and plug it into the other.
Okay,
I'm guessing this is why you have 2 hours.
Well, it's
Nine
ours,
hours,
so
so
just
you're-
ignore the facts, yeah.
But what it consists of is, a good example where we use that kind of stuff is if you have a function that deal with property and profit, deal with profit, and you have another function over here dealing with like how much you pay employees, and if you have 10 employees, you get whatever. If you put that function inside there, now you have a profit equation based on how much you pay employees. So then you just plug in what you pay for employees and it'll tell you how much you're gonna get for profit. So you can kind of plug in equations after another, and I'll tell you one thing you have to plug in, and it'll give you all the information. And that's kind of why we use the function.
So then on 94, we're just eliminating it.
You should graph it, I think, it says graph it.
Yeah, you.
Mr. Fisher, trivial crap isn't working on the Wi-Fi. For now, cool.
Been trying on that phone. Not right now, but you show me what's going on.
Oh, it's in there.
Trying to phone. And my name is Dennis Bishop, if you want to tell me. I did actually have a good round last night, I couldn't find the data. That is round 2, we're tied 0-0, I did 6 in a row. Just round the row, so.
That sounds like fun. There's a new one. I go get a new one.
So, try it in there, I know Trivia Crack, I'm guessing if you try your iPad at home with Trivia Crack, it'll work, I gotta go and watch.
Like, you can just.
Yeah, we'll just have to talk to Ray. So when you have a squared, if it's 2x minus 2 squared minus 1, you don't worry about the squares. You just would add 2 to your x's, and then times divided by 2 minus 1.
Still a parabola though.
Yeah, still parabola, use your parabola for a minute.
But that's okay if we still like break them.
Yeah, it's okay, I don't, it doesn't hurt to write it down. I just want, I don't know this class, I don't want to do more work than me.
That'll happen.
Especially Isaac. Eating 3 hours a night. You got a couple people eat that.
Yeah.
You want us to
Nah,
do
it's
all
okay.
the graphs?
If you just do the file graph, it's fine.
Are you here for school?
I'm lined up in the setup, so I'll be here probably.
Oh.
I wish our class size was smaller.
Some of the, yeah, this is so done.
So I can cross country.
Eric.
Medical and go school.
Eric never.
And pause.
Eric never. You didn't miss class. Yeah. He gets so mad that we don't.
Who was it? I just need to make you back, sir. You can't make mistakes.
I'll order all of these that I got.
Beautiful. That was perfect.
This isn't a parabola though. Yeah, it's really scrambled. Yeah, but you have to read them. Yeah. I
Well,
got
don't
that.
square it, Brandon. Make sure not to square it, otherwise you'll get like a,
No, I did square it.
then you should.
Max still said it's still yeah, it should still.
It's a really Sharpie.
Oh, we took these ones.
If you guys get a really Sharpie,
I got 3 on the same one. I don't think mine's gonna be good. Yeah, I didn't do it right, so I have a straight line.
curly.
I think
It's
I
still
was
square.
Oh, but that'll be yeah. But you don't square the numbers.
No, you have the original set.
Yeah, it's a really sharp
Okay,
one.
and then you apply, so negative 2.
No, I know, I did it wrong. I know I did. I don't know. That's, I said I did, but I did it wrong. I don't know what it is.
Okay,
Yeah,
so
I did it
you could just graph your original problem. Okay, so it's gonna be your x by 2 is gonna go to the right one down.
Oh, okay. I just. There.
So first, your x's are gonna be plus 2. Every x is gonna be
Oh, what
plus
did I do?
2. And And then all the y's are multiplied by 2. So it's like 8. And then you subtract 1, so it's 7.
I got that on set. Is that what you're doing?
Mr. Fisher, it's really hard to see which point is which, but
Can I go to the bathroom quick? Go down to the.
oh boy, it's gonna be a long night, it's not good. 66. Yep.
Not too much of that half hour video.
Are you guys all wearing costumes? Oh, Nate, I have that red costume.
Good thing I already watched it.
I'm
It
going
was
through, but then I got
10:40
to
and I like just finished watching 160 and then I looked at 170 and it was like 30 minutes. Okay, do you want
That's why I
to
didn't
go
know this weekend.
I was at, dude, this is the latest I went to bed, it was like 10:30, I was
Like,
like,
then you have to wake
It's
up in the
north,
morning.
I don't know.
7. I'm sorry about for this long.
I thought it
It was
was
so
back.
hard to be in this year.
That's the thing, I'm like, oh, I should watch TV. I'm like,
It's not
no, I
Halloween
shouldn't.
yet, so
Yeah.
I can.
I think my drives are on.
No, that's pretty bad. It's 2 hours, something like that. One of them must be open.
0713
They started at. And then changed it. Here, 42. I might have wrong.
0713 2-13347.
I got 07.
42, that's fine, right?
Yeah, I don't know how.
Just depending on how big your space between the numbers are.
How do you get
Close to
3
the
when it's
open,
1 is the.
No, you just be open.
It would be 1, 2, because you have to multiply by 2 the y's, which
Yeah, 2 minus
The
1.
y's.
Yeah, 2 minus 1 is 1, so it's 1. I think that's
well, congrats, Caleb. Full title of rookie.
What?
Everybody, calm down.
Simple rating.
Back up, boys.
Who's born into the knowledge.
We did it with
You
family.
really should know this.
That makes you left us.
You can understand that's not a couple of the general. You get at least
Oh,
like
it's
that
so
much.
funny. Yeah, literally just the method.
I mean, that's like if you're not studying.
Oh,
What?
No,
I mean,
like
like,
she
We heard
no matter who
some.
you are, you should know like Texas California or the state you live in, the
No,
states
I
around you.
understand.
You know, like the
I
obvious
love
ones.
going to these places.
Hey,
Washington, Oregon, Mr.
So it's like,
Washington on top next.
we're not doing that.
I didn't know that.
No, literally, me and Dirk.
No, I always mess it up. Oh, I swear else you can't do that. So Mr. Fisher, if it's g of x equals square root of x plus 2, do you have to use all positive numbers? Yeah.
You're gonna use negative everything.
Negative
But
2.
then you could put, it's not like your regular function, it's x squared of x.
Yeah.
Okay, which is, we're gonna use all positive, right?
Yeah.
Then when you move it, it's gonna be negative numbers.
Oh,
Yeah, group. Yeah, cause that's still like, just Corbin, figure out space stats, maybe it's not so. Corbin can just use it.
Right, so is that just like your